Welcome to Study by Yourself, and in this video I'm going to talk about how to name binary compounds of bases. Binary compounds of bases. Now when we say binary compound of a base, what does it mean? Now binary compound of a base, what you need is a metal plus a hydroxide ion. So a metal plus a hydroxide ion is going to give you a base. Now one thing you need to know is that metals have a positive charge. So positive charge. And what you need to know is that hydroxide ion has a -1 charge. So it is OH minus. So it means that since the charge is -1, it means that the valency is 1 and the charge is -1. Yes, so the valency is 1. So in order to name binary compounds which are bases, you need to know the valencies of each of the elements, the metal plus the hydroxide. You need to know the valency for the metal, and you already know the valency for the hydroxide, which is -1, so that you can do the crossing. So with the first one, we have lithium and a hydroxide. So lithium, Li, and then hydroxide is OH. Now, how do you determine the valency for lithium? Now, all metals have XX electrons to give out. So it means that all metals have a positive charge. So lithium, for example, is the third element among the first 20. So hydrogen, helium, lithium, which is the third. So if it's the third, it means that the first shell takes 2, the second shell takes 1. Now, I've said this in several of my videos that when the first shell, the first shell is fully filled, with the lithium. But this is what I wanted to say, that to determine the valency of an electron, when the outermost shell has 1, 2, or 3 electrons on the outermost on it's going to lose. So when it loses, it tends to have a positive charge. And all metals fall in this category. Now with the other part, when it has 5, 6, or 7, it gains to add up to 8, which is not our focus for today because we are dealing with metals, and metals fall in this category. Lithium has 1 electron on the outermost shell, so it's going to lose the 1. Now when it loses the 1, lithium now forms a +1, has a +1 charge, but the valency is 1. So lithium has a valency of 1, which has a valency of also 1 because it has a negative charge, -1, so the valency is 1. So when they cross, this is what's going to happen. Now this thing I did here, we are going to do same for all the questions we are going to take. So Li, so lithium is 1, then OH. So how are we going to call this? We are going to call this lithium hydroxide. Now, binary compounds end with IDE, the suffix IDE. So let's look at aluminium over here as well. Aluminium, the symbol is Al. Hydroxide, OH. Now, how do we determine the valency of aluminium? Aluminium is the 13th element, so 2, 8, and then 3. 3 electrons on the outermost shell. So it means aluminium is going to lose 3, meaning it's going to have a valency of 3. So I've also said this, that the valency and then the charge have something in common, which is the charge has the plus or the minus sign. And when you take the plus or the minus away, what you have left is the valency. So OH is definitely 1. So after crossing, you're going to have Al. Now this 3 is going to affect the O and the H. Now when I do this, OH, and I write a 3 here, the 3 is only affecting the H. But what you need to do is that we need to bring a bracket here and here. So we now have what you call aluminium hydroxide. So continuing, we have calcium and hydroxide. Calcium, Ca, then hydroxide, OH. Now, calcium is the 20th element, so it's going to be 2, 8, 8, 2. So 2 electrons on the outermost shell. So since it has 2 electrons on the outermost shell, it means that calcium has valency of 2, OH 1. So you exchange, you're going to have the same thing happening here. You're going to have Ca, OH, then 2 be outside. Why? Because the 2 is going to affect the O and the H. So zinc is here. Zinc, Zn, and then OH. So Zn, zinc. Zinc has a valency of 2. Has a charge of +2, so valency of 2. OH is 1. So you're going to have this. So you have Zn, OH, 2. Now, copper is a transition metal. So copper, Cu, we have copper 1 and then Cu +2. So I'm going to do for both. So we are going to have, for the first one, copper is Cu with a valency of 1, hydroxide OH. So 1, we are going to have this and that. So with this one, I'm going to have copper. So you're going to have Cu. Okay, I need to write it somewhere else. CuOH. Now, since this is CuOH, it's going to be copper 1. Why copper 1? Copper 1 because now copper could either be Cu +1 or +2. So for you to tell the one who is reading that it's copper 1 or copper 2, you need to state the valency of the copper you used. So copper 1 hydroxide, this is how it's going to be. Copper 1 hydroxide. You write the valency as a Roman numeral in a bracket. So what if it's copper 2? So you're going to do the same, Cu and then OH. So since you are using copper 2, it's going to be Cu2, then OH is 1. So you're going to have Cu, then OH, then 2. Cu, then OH2. So this one is going to be called copper 2 hydroxide. So we have copper 1 hydroxide and copper 2 hydroxide. So when you are dealing with any element which has more than one charge, you know what to do. You know what to do. Now, for the purpose of, let me just go over again. So I said with binary compounds, which are bases, you have a metal and then a hydroxide ion. Then you get a base. Now, most metals have positive charges, so you definitely know that your charges are in a positive, or they are cations. Then hydroxide has a negative charge. That's what you should take note of. It's -1. So the valency is 1. So what you need to do is you always need to do your crossing. When you're given hydroxide ion and then the metal, make sure you know the oxidation number or the valency of the metal, or else you'll not be able to write a correct chemical compound. So thank you so much for watching. My name is Sir Prince, and keep studying by yourself. I'll urge you to subscribe if you've not done so. Like and share.